Hello again, guys. So, as I promised, as I said in the previous video that I just showed you, we solved this problem, but the first time that we solved that problem, we did it using law of sines and cosines, just to show you that we could do it in that way. Remember, we draw parallel lines, we form the parallelogram, we state where the resultant force is, and then we start working with the law of sines and the law of cosines in order to find all the unknowns that we have over there. Now let's try to do it a little bit different, and bear with me because usually I don't solve, most of the time I don't solve the problems beforehand. So I'm solving this problem as I'm speaking with you right now, and I might mess up. It doesn't happen very often, but it might happen. So let's try to do that. What is using force decomposition? Basically, what we are doing is doing what is called force resolution, and that means that we are going to find the components of each one of the forces. I know that this force 1, for example, has a component in this direction, in x, and has a component in this direction, in the y direction. And I know the other force, F2, likewise, we have a force in this direction, a component, and another component in this direction, in the y direction. How do you calculate those forces? Easy, because first you have here this little triangle. So and then what you do, I'm sorry, when you do this type of force decomposition, you get two components going in x, two components going in y, and you just work them out. And you can find the resultant force by recomposing these two forces, summation of forces in x, summation of forces in y, and then we say that the resultant force is going to be the square root. You know that from physics. The square root of the x component square plus the y component square. So let's do it in that way. Let's first calculate this force here. That force over there, whenever you have this little triangle, I'm pretty sure that the majority of you know that you can calculate this angle. Yes, there's nothing wrong with that because this angle is the same angle as this angle here. How do you calculate that angle? You can say inverse tangent of 12 divided by 5. You can say inverse cosine of 5 divided by 13. You can say inverse sine of 12 divided by 13. But the idea is that if you have that triangle, use it because it's easier to do that. Basically, what the problem is telling you is compare this triangle of forces with this triangle of geometry here because they are similar. That's what they are saying. So if I have to find the horizontal component, I just have to get that value in the little triangle divided by the hypotenuse and multiply by the value of the force. And that will give me the value of that component in the x direction. This is 2100, right? Yeah, 100. So this is the value of the component in the x direction, 100. And this is in pounds. What I just said is this. You have a big triangle and you have a small triangle. This is 5, this is 12, and this is 13. And in this case, we know this side because this side in the fourth triangle is 260. So what I'm doing is comparing side by side. I can say that 12 is at 13, for example, like this side is at 260, or 5 is at 13, 5 is at 13, like this side is at 260. And when you solve, this is what you get. Look for the component in the y direction. Look for this component now. I'm looking for the F1y. Let me put here F1y in this side here. So basically what I'm saying is that the side F1y divided by 12 has to be equal to 260 divided by 13. And when you solve, it's basically what I told you before. You get the parallel side 12 divided by the hypotenuse and multiply by the value of the force. You see, in this case we were looking for the horizontal, that's why I use 5. In this case, we're using for the vertical. That's what I use, that one over there. And then you do this, and then it will be 120, 240, I guess. So that's going to be 12 divided by 13 multiplied by 260, 240. So the other thing that I advise you to do is stop depending so much on the calculator and try to simplify whatever you are calculating. For example, this is 26, right? And this is 13. So 26 divided by 13 is 2. I have this 0, 20. 20 times 1, 20 times 12 is 24. Plus 1 0, 240. That's the way I calculated, 240. Now be very careful, because if you're going to work in the direction of the axis, as you should, remember this is the x value, and this, whenever you have that letter over there, that letter indicates a positive direction for the x-axis, and this is pointing to the left, meaning it's going to be in the negative direction. So this value should be negative, but we're going to do that when we do the addition. And this value is pointing up, so that value should be positive in this particular case. Okay, similarly, now we're going to be working with decomposing these two forces here, which is, now I have the angle 45, and you know that this force here is just going to be 310 times cosine 45 degrees, and this one here is going to be 310 sine 45 degrees. How much is that? 310 cosine 45, 219.2 pounds, and sine and 45, sine and cosine 45 is the same, 219.42 pounds. Now we have all the forces in x and y. What do? We calculate the resultant of the forces in the x direction. Okay, let's work in the x direction. This is the x component of force 1, but I'm going to put it negative, okay, just to indicate that goes to the left. So negative 100. And this is the x component of F2, and I'm going to put it negative as well, 219.2, meaning this is going to be 319.2, or no, 0.2, no, it's 0.2, you see, and I put here 42. And you didn't correct me. I mean, please, pay attention, correct me, yell at me. Okay, now we have that over there. In the x direction, be careful when we calculate our resultant force in the y direction. Now we have this one. This one is positive. Why is it positive? It's not positive because it's up. It's positive because it's pointing in the same direction of the y positive axis, which in this case is up. So that value will be 240 positive. And then this other one here is pointing down, so that means that will be negative, minus 219.2. And that is 20.8, but let me do it anyway. 240 minus the previous value, 20.8. 20.8 in the positive direction. If I want the resultant force, it's just the square root, remember Pythagoras theorem, of FR, x squared plus FRY squared. So the resultant force will be a square root of 319.2 squared plus 20.8 squared, and the value for the resultant force will be, this is the 20.8, let me square that, plus 319.2 squared, and then a square root of that. Square root is elevated to the 0.5, that's 319.88. 319.88 pounds. Now, we need the direction. Of course, measure counterclockwise from the positive x-axis, yada, yada, yada. What I do, and I still do that, once I have these two, I plot them out. I plot them out just to be sure the direction that they are going. So basically, if this is my 0 and this is my x and y, I do kind of a representation of this. So I put like 319 going in this side. This is FRX. And then I go up 20.8, 20.8, something like this, 20.8. And my resultant force will be this one here. Why do I do that? Well, I do that because now I have this triangle that I can use to calculate this angle, because the one that I'm interested is the total one, right? So if I calculate this angle and I subtract 180 minus that angle, I have the direction. Now this value, as I say, the y component is 20.8, now in absolute value, and this one here is 319.2. And then you can use any, and of course, no, 319.2 is this, I'm sorry. 319, I told you this is live, I'm not rehearsing anything. 319.88. And this, that was 319.2. Oh my god, 319.2. Okay, 319.2. So now if I want to calculate this angle alpha, I can use the tangent, which is the one that you are used to all the time. But I can use also cosine, and I can say inverse cosine of this divided by that, or I can say inverse sine of this divided by that. It's the same thing. I'm going to use the inverse tangent because it's what you are more used to. 20.8 divided by, and you always say, oh, Fy divided by Fx, 319.2, and that will give alpha 20.8 divided by 319.2 inverse tangent. That will be 3.73. And once again, if you need the direction from the x-axis, 319 is this one, this little wedge here. But I need this one, and that will be 180, the direction, 180 minus alpha, and that direction will be, we calculated before, right? 176.27 degrees. Now, using force decomposition, finding components, adding components, using sine and cosine law. Two ways of solving the same problem. You see, the flow is way better than this one. In my opinion, it has more physical and engineering sense to do it in that way. But there are some problems that are really easy to solve using law of sine and law of cosine. Keep watching, guys. Thank you for watching. See you next video.